Alright guys, yesterday we solved systems of equations in 2 variables. They were doing them in 3. Pretty challenging today. Hang in there. Here's the rules or steps that you can do. Only 3 things you can do. Number 1, you can interchange any 2 equations you want to anytime you want to. Okay, that's completely legal. You're allowed to just move them around anytime you want. Number 2, you can multiply an equation by anything you want to as long as you multiply both sides by not a 0. Number 3, you can multiply an equation by something and add it to another equation to make something go away. You can do eliminations, is what it's saying. We're going to do like 3 eliminations in one problem to make it work. Rule 4 is not on here is you can't just sit and stare. You got to try, and you can't give up. Don't give up. Just keep on going, because there's going to be times when you're doing this, you're like, oh my gosh, you're going to want to just hang in there. I'm going to show you one example and only one. So take good notes on it. Try your best just to get it. Maybe watch it the first time, then go watch it again. Make sure you can get it. Just take about a minute and a half or so. So here we go. Okay, I'm going to give you a system in 3 variables like this and say solve it. I'm going to do the same method every time in class tomorrow and on this video that I do in this video, so you can see a consistent way that will work every time. The first thing I'm going to do is I'll usually put my smallest x in my top equation. That is not a requirement. I'm going to recopy it right here. Recopy my first equation. I'll be honest with you, it is not going to change the whole time as I go through this process, but I am going to use it. What I'm going to use it for is to get rid of the x's in the other two. So I'm going to get rid of that x right there. So I'm thinking to myself, what do you add to 4x to make it cancel? And the answer is negative 4x. So I'm multiplying the whole top equation by negative 4x. So make it negative 4x plus 8y minus 12z equals negative 44. Now I'm just going to add that to the second equation, which is 4x plus 2y minus 3z equals 4. Alright, when I add those, the x's are gone. I get 10y minus 15z equals negative 40. Now, one thing we've already talked about in the last slide, one of the things you can do anytime you want to is you can multiply an equation by something that you want to, as long as it's not 0. So what I'm going to do instead of multiplying is I'm going to divide that whole equation by 5 to make the number smaller, and that's going to become my new second equation. So it's going to be, let's see, 5 goes into 10 2 times, that's 2y. 5 goes into 15 3 times, that's negative 3z. And 5 goes into 40 8 times, that's negative 8. So that's my new second equation. I'm going to do the exact same thing with the first equation, except now I want to get rid of that 3x in the bottom one. So to do that, I got to multiply the top equation by negative 3. So I'm going to make it negative 3x plus 6y minus 9z equals negative 33. And I'm going to add that to the third equation. 3x plus 3y minus z equals 4. I'm going to add those together. That's gone. I have 9y minus 10z is negative 29. That, guys, is my new third equation. 9y minus 10z equals negative 29. So let's recap a little bit. I took my first equation and I left it the same, and I brought it down here. I also used my first equation to get rid of my x in my second equation, that 4x, by multiplying it by negative 4. And I also used it to get rid of 3x by multiplying the first equation by negative 3. So I've got rid of my x's already. Now what I have to do is I'm going to recopy my first equation one more time, just like this. Recopy my second one this time. Now what I've got to do is I got to do elimination one more time, and I need either the 9y or the 10z to go away. Doesn't matter which one, but one of them has to disappear. Neither one of them make that really simple to do. So what I'm going to do is I'm going to get rid of the 9y, which means I'm going to multiply the second equation by, a different color, second equation by negative 9. So it gives me negative 18y plus 27z and 72. Now I'm multiplying the third equation just by 2, because that's going to give me a positive 18y, which is what I wanted, minus 20z and negative 58. When I add those together, that gives me 7z over here, and over here gives me 14. That is my new third equation. 7z is 14. Now that's what I was going for. This is also sometimes called the triangular method because I started with three variables up here at the top. I went to 3, 2, 2. And down here I'm at 3 variables, 2 variables, 1 variable. So it kind of looks like a triangle. But what I can tell already is I know z is 2, which is very important because 7 goes into 14 2 times. Now I'm just going to back substitute to find my x and my y. So I'm going to plug the 2 back in the second equation where the z is. 2y, 3 times 2 is 6, will be 2y minus 6 is negative 8. Move that 6 over, and that would give me 2. So y is 1. So here's what I know: y is 1 already. I know z is 2. All I need to do is find my x. I hope you're not about to pass that already. So what I'm going to do is I'm going to plug both of those numbers back in my top equation. So it'll give me x minus 2y. Remember, y is 1. 2 times 1 is 2. Plus 3z. 3 times 2 is 6 equals 11. So that's going to be x plus 4 equals 11, which means x is 7. So my answer there would be 7, 1, 2. Okay, I just noticed a mistake, and it's gonna happen in these problems sometimes because they're so tedious. Right here, I don't know if you can see where I'm pointing. Let me see here. Looking right here where my y's were, right there. When I move the 6 over, it should have been negative 2. So my y should be negative 1. So when I plug in a negative 1 instead of positive 1, that should be a positive 2 right there, which means that's an 8, which means that's a 3. My x should be 3. So sorry about that. 3, negative 1, 2. And guys, that's going to happen to you sometimes. So I'm kind of glad you saw me mess up on the video. Because the hardest thing, it's not this. I'll be honest, the steps to doing these problems, even though it looked pretty bad, the steps are not that hard. It's just elimination like we did yesterday. The hard thing is getting through all those steps without making a mathematical mistake like I just did. So it'll be a little bit challenged, but hang in there. We're not going to do many of them tomorrow, but enough to get you comfortable with the process anyway. I need you to understand the process. So if you need to, at least go back and watch that slide one more time so you feel a little bit pretty good about it, and tomorrow we'll work on it quite a bit. See you then.